Hey guys, I'm just going to explain a little bit about basic excision repair and nucleotide excision repair because it's something that's always confused me. So for basic excision repair, it's to remove deaminated bases, and for nucleotide excision repair, it's to remove the thymine dimers. So in basic excision repair, we're going to remove a base. So originally, this right here, that was a cytosine, and because of deamination, that became a uracil. And we want to remove that uracil. So in basic excision repair, we're first just going to remove the base, and you can contrast that to nucleotide excision repair in a second. The enzyme we use to remove that base is called a glycosylase. There are different specific types of glycosylases. If you look in your own lecture, we had a uracil glycosylase, if I can move his finger away. You had a uracil glycosylase that removed that particular base, but you have a bunch of different types of glycosylases that come and remove depending on the situation that's needed. So once we remove it with the glycosylase, you have what's known as an AP site. The AP site is that apurinic or that apyrimidinic site. So that's what's left over, and if you look at your lecture here, it leaves an apurinic or an apyrimidinic site. Now we have this empty site here. We want to be able to fill it with the regular base. How are we going to do that? Well, the way we do it is we need DNA polymerase to come in and to fill it in. But we can't fill it in because right now we have a backbone here. So what we need to do is we need to make a hole in this backbone. And once we make a hole in that backbone, the DNA polymerase can come in and fill it in. So how do we put a hole in that backbone? We use what's known as an AP endonuclease, and pay attention to the word endo. The word endo for endonuclease means that this particular enzyme can cut in the middle of the DNA strand to create a nick in the backbone. As opposed to an exonuclease can come in from the edge and start chewing it up like Pac-Man. Okay? So endo is for the middle of the strand, exo is from the end of the strand. So you first have an endonuclease come in and make a little nick here in the backbone, and then an exonuclease can come and remove a bunch of these DNA nucleotides, and then the polymerase can come in and fill it back in, and then finally the ligase will be needed to seal that backbone at the end. This example is a little bit different from the one from your class because in your class they just showed it with a lyase removing one particular nucleotide, but I think this is just a better way of thinking about it, and this does exist in real life where it removes a bunch of nucleotides like this. Now for nucleotide excision repair, as opposed to base excision repair before, instead of removing just the base, we're removing all the nucleotides. So just ignore UVA, UVRA, and UVRB. These are the same as the XP enzymes, and you guys should memorize the XP enzymes. This is just for E. coli for this particular example. But the principle is the same. You have UV light hitting these thymine and creating a thymine dimer. And you don't want that thymine dimer there. As you can see, it kind of bulges out and that DNA is messed up. So what we do is we want to remove all of these nucleotides here. So you have proteins that come, bind, and nick it. Nick the backbone. These are, again, endonucleases. And they nick the backbone, and you pull out the entire nucleotide. So you see all of these nucleotides here in the chain. They're just all pulled out at once. Then DNA polymerase will come in again, will fill it up, and then finally the ligase will come and seal it. Okay, and just make sure that when you guys are studying it, know these XP C and XPB. XP stands for xeroderma pigmentosum, and make sure you know the difference between the global genomic repair and the transcription coupled. The main difference is the protein in the beginning, but everything else in the later part of the pathway is exactly the same. Okay, well, thank you guys, and I hope to see you again.